Example 6, using the U.S. population data from the given table, find an exponential regression model and use it to predict the population of the U.S. for 2003. Compare the result with the number in the table. So what we want to do is type this table in to our calculator and then perform exponential regression. So, oh, how convenient. Those numbers are right there. And here's my calculator. So we want to go to... Actually, that's not convenient. That's not the right problem.
Haha.
There it is. Okay. So a lot of times whenever we're doing this, we pick, instead of putting in 1900, 1910, and all those, we make our first year be 0.
Oh, I went ahead and went with 19s, but
well,
I can do zeros.
Both models, like, they end up giving you the same idea, but for some reason it tends to seem like it works out better if we do 0, 10, 20, and stuff like that. And that's typically what the book will do. So where do I go here? Second list. Yeah, so second stat. You want
no, just stat.
No, just stat.
Yeah.
Oh, we want to edit.
Here, you want to edit your list.
Your list. So in the first list, we're going to put in the years. So 0, 10, 20, 30, 40, 50, 60...
Wow, this population
70,
is, I feel like it's growing exponentially here.
80, 90. Well, then it's a good thing we're going to use exponential regression. And do we want to put 2003 in there?
It would be 1,000. It would be 103.
No, I mean, but do we want that data in there
yeah,
as well?
We need that data because it's going to help create maybe a more fitting situation.
Okay.
Maybe lose my place.
I am so sorry. That's not at all what I was trying to do.
So it was what you were trying to do.
Why would you say that?
All right. What are we regressing this to? Are we regressing this to
We're doing exponential regression.
X list.
Okay, well, you guys probably know better than I do if I actually typed in all the right things. So I'm going to quit out of that. I'm going to go to Stat, go over to Calculate, and we want to find exponential regression, which they use EXPREG.
XREG.
XREG. And we do want list 1 and list 2. And so we press Calculate. Dimension mismatch. That's...
It's no bueno.
Not what I wanted. That's not what I wanted.
Uh-oh.
So.
Why am I not getting the thing here?
I got it off somewhere on mine. 76.2, 92.2, 106, 120, 122, 151, 179, 203, 226.
All right. I got an exponential reg of...
Okay, am I just giving up? Okay. Yeah. You got
Ready?
an exponential reg.
I got an exponential reg. Okay, here's what it's going to say. It's going to say something along the lines of a times b to the x. All right? And then it's going to tell you that a is 80.8677. B is 1.01275. And then it's going to give you some other values down here. There's like an r squared value. That's really kind of important because it tells you how good of a fit it is. The closer r squared is to 1, the better the fit.
Right. And that's a statistics sort of thing.
Right.
So if we actually plug A and B into our model here, we get this model. To compare the data for 2003 to what we got on here, we need to put 103 in for X.
Oh, we're seeing how good of a fit it is?
Yeah. So put 103 in for X.
All right. Hold on.
Did you just like space out there or something?
No, I graphed it, so I got to get my window ready here. So let me just get out to...
Why didn't you just put 103 in for X?
Because it shot me to my graph when I created it. Give me just 1 second here.
Okay.
We're all good. We're all good here. We're all fine here. How are you? What movie is that from?
Star Wars.
Yes. And spoken by. Spoken by?
Han Solo.
Han Solo.
A New Hope.
Yes, indeed. All right, so X is 10. No, X is 103.
X is 103.
Menu. Trace. And I get 298.501.
298.501?
Yes.
Well, that's okay.
That's
pretty
not
close.
bad. That's not bad. It's a pretty close estimation.
That's 8 million away.
8 million, when you're talking about hundreds of million, is, not that much.